Take an aspirin. The Big Bang literally happened here in this room, like where you are standing now. Take another aspirin and make yourself comfortable. Today, we're going to dive close to the beginning of time at a point in the history of our universe, where it, contained in a volume ridiculously small compared to its immensity today, was the scene of an event of unparalleled violence. While it was entirely heated to billions and billions and billions of degrees, before starting to cool due to the expansion of space. And above all, we will see that as strange as it may sound to our ears. This description of the Big Bang is still far from doing justice to what was truly the most mind-boggling phenomenon ever to occur in the universe, since it produced the universe itself. Because the representations we have in our heads of the Big Bang are often false and, at the very least, imperfect. And to try to account for the almost nonsensical nature of what the Big Bang truly was, we're going to debunk, one by one, the misconceptions that revolve around this incredible event, and try to focus on the exact spot in the sky where it took place. Before trying to take a look at what happened before and talk about the size of the current universe, and at the beginning of time. That said, let's get to the crux of the issue. To try to construct a mental image as faithful as possible to what this mind-boggling event was. Let's start by tackling what the Big Bang is not. When we talk about the Big Bang, we very often tend to imagine some kind of gigantic explosion at the origin of absolutely everything that exists in the universe. And our brain, like our stories, almost instinctively produce the image of a gushing of matter, light, energy, space, and time from a derisory volume. In other words, the Big Bang would be the precise moment where, after being concentrated in a volume of almost zero size and phenomenal energy density, all the matter and light of the universe would have suddenly been released, like violently propelled in all directions into an expanding space. Although absolutely all illustrations that try to give an image fall into this pitfall of representation. The Big Bang is nothing like an initial explosion of a gush of matter and radiation that one could observe from an external and distant point somehow located outside of the universe. In fact, the term Big Bang is not appropriate to describe the physical phenomenon it represents, because the universe contains itself from the start, and no image will ever truly be able to do it justice. Close your eyes and give me your full imaginative power. And focus intensely. Try to erase the image of an explosion within you, replacing it with a creation ex nihilo of space and time. And there, I think you can see how quickly our abilities to construct images of the Big Bang are confronted with the unimaginable. So I'm going to try to rephrase it in words. The Big Bang is not an explosion in the universe that would set light and matter in motion through space-time, like, for example, the explosion of an insane amount of trinitrotoluene. The Big Bang is literally the expansion of space. I repeat it for you, but also a lot for myself. At the time of the Big Bang, no particle is actually moving in space. It's the space between these particles, which, in the midst of a growth crisis, expands and stretches. And this expansion takes place at every point in the universe. In other words, during the Big Bang, the universe itself explodes. It's the space-time and the dimensions of the scene that are immeasurably expanding. At no point is space-time a kind of fixed and immobile dimension support on which the event unfolds. It's a conveyor belt, expandable and dynamic, which can even bend and deform. Once this idea that would give a headache to an aspirin is digested, our mind is dying to represent this expanding universe, like a kind of point suspended in a dark and borderless void. But the Big Bang is not something that happened inside something bigger. There is nothing around the expanding universe. It would have been impossible to observe the Big Bang from a distant observation post, because there is no outside. There is no place to retreat, since outside there is no place. The universe is not expanding into a space devoid of matter and energy pre-existing it, nor into a void larger than itself that it would fill as it progresses. Everything, including space, exists in the universe. Yet, almost inevitably, our thoughts can't help but represent the universe as having surfaces, boundaries, and edges. But no image can show that the universe doesn't extend into nothingness. It contains everything that exists and has always contained alone the entirety of the available space that it generates itself by expanding in its expansion. To put it another way, the expansion of the universe is not an expansion into something else that it would push back the lights and edges of. It's an internal expansion that increases the available space volume in gargantuan proportions. Aspirin, present and future. Having, surely unsuccessfully, tried to rid your imagination of anything remotely related to images of explosion and deflagration, while having, a bit vainly, tried to pulverize the concepts of borders, limits, and edges. It's time to try to dynamite the idea of a gushing of space, time, matter, and radiation, starting from a single point, which would then have unfolded in all directions. Because the expansion of space did not start at a specific point, but at every point in space. Points that are no more at the center or on the periphery than the others. Because the fact that there is nothing outside and pre-existing to the universe in which it would expand leads to another strangeness. Namely, that no place in the universe is more special than another. The Big Bang was never a localized event, located precisely somewhere, like the explosion of a gigantic firecracker would be. The Big Bang has no point of origin. It did not take place in a specific location, but everywhere, absolutely everywhere. And this is not a poetic license. There is no place in the universe where the Big Bang did not occur. It happened literally everywhere around us, at the exact place where I am, as well as where you are. It took place in your mother-in-law's living room, as well as at the center and on the edge of all the galaxies in the universe, before all these things formed. If the Big Bang had been a localized event in space, it's worth noting. Then we would see matter at large scales moving away, with different speeds from a particular point. But this is absolutely not what we observe. In all directions, galaxies are moving away from each other uniformly, and the greater the distance separating them, the faster they move. Thus, no point in the cosmos is the center of the universe. And now that we've thoroughly decentralized, we're going to try to debunk an idea that's been propagated by practically everyone, myself included. And that would suggest that the primitive universe was initially very small, except to say this is immensely false because we do not know the size of the entire universe. Remember that all we can currently see, and what we call the observable universe. It's only the part whose light has had time to reach us since it's been able to circulate there. At the Big Bang, the universe was compressed into an infinitesimally small volume. In reality, we need to understand that we're only talking about what we can see today. In other words, even if, at the time of the Big Bang, everything that is now contained in our observable universe was in a ridiculously small volume of space, the entire universe itself may have been huge or even already infinite. Take an aspirin and let me explain. The observable universe is the part of the cosmos that we can see right now. And this sphere of 90 billion light-years in diameter is centered on Earth, includes all parts of the universe whose light has had time to reach us. But space exists and expands well beyond the visual limits of this sphere. And the extent of existing universes, beyond what we call the cosmological horizon, depends on the curvature of space, its geometry. By studying the light coming to us from the farthest regions of the observable universe that we can observe, we have been able to determine that the radius of the entire universe is, at a minimum, 500 times larger than the dimensions of what we can see of it. Yeah, it's big. So, in terms of volume, the entire universe is therefore at least 125 million times larger than the portion we are able to see. And we're only talking about the lowest possible estimates here. In fact, the finest measurements we've been able to make. It is entirely possible that the entire universe may be infinite, because the geometry of space seems flat to us at very large scales. However, if the universe as a whole is perfectly flat, then the observable universe is just a drop in an ocean of space-time of literally infinite extent. And beyond the limits of our observable universe, the total universe continues on, indefinitely. However, if the universe taken as a whole is infinite today, and it may well be, then the absolutely staggering consequence is that it has always been. And it was already at the beginning, in a state certainly compressed, of a staggering density, while still being infinite at the time of the Big Bang, where the entire universe was simply an infinity exceedingly smaller than its infinity today. I'll give you a second to let the immensity of that idea sink in. One more if you want. From here, rest assured, if you didn't grasp everything, it's because you're sane. Because no one is wired to visually juggle with infinities. And I imagine that you are, like me, besieged by fabulous questions such as, how can an infinite space be expanding? How can a universe that is already infinite at the start become even bigger? And there, one must come to terms with it. There is no way to fit the image of an infinite-sized universe into a finite-sized brain. Our mental representations, always immersed in a world where all the things around us have limits and an end, are faced with an idea without an image. And only mathematics are capable of taking up the challenge of infinities and can help us confront the staggering dimensions of a space so vast that, faced with it, our imaginations inevitably end up surrendering. In fact, to avoid straining their neurons, physicists, when studying the properties of an infinite and expanding universe, rarely talk to each other about its size, volume, or radius. When they discuss the dimensions of our expanding universe, they prefer to talk about scale factors, that is, how the distance between 2 points in space varies over time. Don't leave, you'll see it's fascinating. By convention, we say that the scale factor of the universe is currently 1. When it was 0.5 several billion years ago, all points of the universe, observable, but also as a whole, were twice as close to each other as they are today. When this scale factor was 0.25, all points were 4 times closer to each other. In short, you get the idea. Now, let's push it to the limit, as close as it's possible to go. As we get closer to the beginning of time, the universe shrinks. All points in the universe continue approaching each other. It keeps getting hotter and denser. But you can certainly halve the distance between every point in space an infinite number of times. If it is infinite today, then it remains so even near the Big Bang. Because a number multiplied by infinity, no matter how small, always gives infinity. And as strange as it may seem at the time of the Big Bang, even if the visible universe was reduced to the size of an atom, the entire universe was already infinite. Like me, you've likely heard that the Big Bang describes the moment that follows its occurrence, the one where all points of the universe were located in the same place, not excessively close to each other, but literally in the same place. Except that this idea must also be chased out of your heads. Let's play a little game. If you take the scale factor from incredibly small to the value of 0, then absolutely all points in space end up as 1. Our three-dimensional universe no longer has any, and we observe on paper the birth of a singularity. A place in space where our equations tell us that the temperature and density of the universe become infinite. Except that despite all the shortcuts taken when they have to talk about the Big Bang to the general public, no scientist truly believes that the entire universe was in the same place. When physicists encounter a singularity, they concluded that their theories are incomplete. And the fact that such an object exists simply means to them that, despite its incredible successes, the general theory of relativity proves incapable of describing the behavior of the past universe. A certain degree of madness in the conditions that prevailed there. And this very disturbing image of incomplete physical theory, which, after being pushed too far, seems to hit a wall, will allow us to finish in style by tackling one of the most often taken shortcuts, namely that the Big Bang would mark the beginning of the universe. We often hear that it started at this alleged singularity, and that the Big Bang was the extraordinary expansion that followed. But the singularity is not a starting point from which the universe would have started its history. It's only, as we've seen, a thick fog. A limit beyond which our current understanding of the laws of nature stops. And with our current knowledge, it is impossible for us to describe what happens beyond that. Thus, as far as the Big Bang theory can go back, it never touches the supposed moment where t equals 0, if such a moment exists. Moreover, the Big Bang theory does not describe to us either the moment from which the universe begins, nor its place of birth. It tells us about what happens from the moment our knowledge of the laws of nature proves to be effective, when all points in space of the observable universe, whether they are located at the edges of the cosmos or at the level of the chair on which you are probably currently sitting, were practically in the same place, but also already moving away from each other at full speed due to the expansion of space. In this sense, the Big Bang theory does not in any way claim to describe the formation of the universe from a hypothetical single point, because it is only able to describe it once it has already started, when everything has already begun. And there's a perfect transition to end this episode by trying to debunk the very idea of a beginning. When we talk about the Big Bang and the associated idea of singularity, we often hear that this marks the beginning of time. This implies the idea that the universe began and, subtextually, that there was something before. But the Big Bang does not tell us about the beginning of the universe, nor the beginning of time. We can turn the question around, but what was there before? In every sense, it will never make any sense. The question cannot be asked, because how can we evoke a moment when time did not exist? Before the Big Bang, we are unable to describe space and time. What precedes time equals 0, it's not nothing, it's not exacerbated void, but literally the nothingness from which space and time have been subtracted. Aspirin before time equals 0 time. Equality like 0 does not exist. Moreover, to evoke the concept of time near singularity is already in itself a misuse of language. And the fact that our theories fail to describe its flow does not necessarily mean that it was created there per se. Thus, the Big Bang is by no means a description of the precise moment of the creation of our universe, if indeed our universe had a beginning. Moreover, even if we are almost instinctively tempted to endow the universe with an initial instant to find it a beginning, nothing tells us that there was not a before, or that it does not exist for all eternity. There are theories today that venture to imagine what we might find behind the hypothetical 0 time. And to generate our universe, some summon giant multi-dimensional strings, others membranes floating in a space of higher dimensions that would have collided with ours, thus creating our universe. Others still assume that our universe has always existed, forming in an eternal repetition from previous universes, like a bubble of matter rising and falling in a lava lamp. Unfortunately, and for now, unlike the Big Bang, none of these theories have been confirmed by experience. Let's summarize everything that has just been said. 1. The Big Bang theory does not tell us. It does not speak of a moment at all, from where would have sprung from nothing, an ocean of matter and radiation. Secondly, it does not claim to explain the origin of the universe. And thirdly, it also tells us nothing about the process that triggered its expansion, if there was one. It describes the period of expansion that allowed a volume billions and billions of times smaller than a pinhead to transform into the dizzying vastness of the deep sky. And the Big Bang theory has such solid evidence that we know the picture it gives us of the first moments of our universe is almost certainly correct. Because this theory is able to explain with unparalleled precision a large number of peculiarities of our universe, such as its expansion, the makeup of the universe, matter distribution on a grand scale, and the existence of cosmic background radiation. What was there before? Why is there something rather than nothing? How did the absence of everything become a first thing? To all these dizzying questions, the answer remains, well, we don't know anything. Unlike others, convinced they hold the absolute truth. And often very sensitive when pointed out, scientists admit what they don't know. Perhaps one day, we will find out how to describe what is happening beyond. Maybe we will manage to construct a theory of the origin of the universe. But in the meantime, we will have to be patient because we do not know. And even if it's not certain that it will ever be possible to solve these mysteries, I remain absolutely astounded by what the labor of a community of human brains has managed to find. There you have it. I hope I have made you feel a bit of the delicious vertigo of the universe that runs through me every time I think about the idea of the Big Bang that took place in this room. I hope to thank you for dedicating more than half an hour of your life to the very first moments of its long existence. You can now close the internet and jump out the window, unless it's the other way around. And before you end up hitting the ground, consider subscribing if you haven't already, turning on the bell, and if you feel like it, supporting this channel on Tipeee.